Hello everyone, welcome to AWSome Pipeline, a cloud native approach to deliver microservices tutorial. In this tutorial, we will be creating a Spring Boot microservice, and then we will be creating an AWS Code Pipeline to deploy this microservice to our EC2 instance running behind an application load balancer. Let's look at the full agenda before we get started. First of all, I will describe what is CI/CD and why do we need it. Next, we will start looking at different tools provided by AWS for CI/CD. We will talk about AWS Code Commit and what are the advantages of using AWS Code Commit. Next, we will look at AWS Code Build service and features it provides. In next section, we will look at AWS Code Deploy service provided by AWS for deployment automation. In next section, we are going to talk about AWS Code Pipeline service and how it is going to help us in continuous delivery. In next section, we are going to take a look at the application deployment architecture and how application will be delivered in the cloud. In next section, we will create a sample Spring Boot application, and once we have our microservices ready, we will create the required AWS infrastructure to set up automation and CI/CD pipeline. In final step, we will set up our code pipeline and configure different stages and perform automated deployment of our microservice. So let's get started. Before we get into the details of this video, little bit about myself. My name is Amardeep Singh. I'm working as a lead solution architect for a well-known financial institution. I'm TOGAF certified enterprise architect and AWS certified solution architect at professional level. I'm AWS certified security specialist and machine learning specialist. I'm Jenkins certified engineer and a big advocate of continuous integration and continuous delivery. You can follow me on Twitter or connect me over LinkedIn. Please don't forget to like and subscribe my YouTube channel for technology related videos. Link is in the description. So first of all, let's start learning what is CI/CD. In its simplest form, continuous integration and continuous delivery is a technique to bring agility in your software through automation. So if I had to define continuous integration further, I will say it focuses on having a central repository where each developer in a team check in their code multiple times each day and takes updates committed by the fellow team members. Continuous integration requires that code build process is automated and given feedback continuously to developers by automatically testing the changes committed by the developer. Continuous delivery is an extension of the continuous integration and require that change committed by the developers are automatically deployed to an environment. It can be a production or a staging environment. Continuous delivery ensures that you have an automated release process and deploy the changes committed by the developer to an environment for validation. In continuous delivery, it is possible that there can be several manual approval processes before you release your changes to the production environment. Continuous deployment is one step further from continuous delivery, where each code change which passes all steps goes to production and released to the customer in an automated way. Now we have a fair understanding that what is CI/CD. So let's try to understand what are the benefits of using CI/CD. So first one is CI/CD focuses on smaller changes, which makes it very simple. Next one is, since you are working on a smaller code change, so it is easy to locate fault and quickly fix them. So it focuses on fault isolation. Each code change to the production makes a risk to the release or to the feature. With usage of CI/CD in smaller features, it is easy to recover from any type of downtime to your environment, and you can quickly restore your environment, which leads to a faster mean time to resolution. Testability of the application improved as you focus on test automation and make specific changes in each release, so it is easy to test. Due to automation in feature-based delivery, CI/CD resulted in faster time to market, so you can quickly make the change in the release to the production. CI/CD resulted in a smaller backlog because you are continuously working, you are not waiting to release your fixes to the production environment. You are releasing each changes each week or each day or multiple times a day. With the automation in feature toggle and blue-green deployment, enable seamless targeted introduction of new production feature to user without causing a downtime. Release cycles are shorter with targeted releases, and this blocks fewer features that are not ready. For example, you are working on a release that involve like several features, and a day before release you found a bug in any of those features, and this bug causes your deployment to push out. So problem here is that you found a bug in feature A, but you have to delay feature release for feature B and C, as well as your changes are staged. But CI/CD solve this problem by releasing more frequently and feature-based releases, so you don't have to stagger your changes. You can deploy each feature one by one. End user involvement and feedback during continuous development leads to usability improvements. You can add new requirements based on customers' need on a daily basis. User doesn't have to wait months to get his her requirement delivered to production. So these are all several benefits why CI/CD improves overall customer experience. Now let's talk about different tools AWS provide to support CI/CD. In this section, I will be talking about AWS Code Commit, AWS Code Build, Code Deploy, and AWS Code Pipelines. These are the different tools provided by AWS to solve CI/CD problems. Let's start learning about AWS Code Commit. So AWS Code Commit is a fully managed source control service that hosts secure Git-based repository. It makes it easy for team to collaborate on code in a secure and highly scalable ecosystem. If you are a developer, you might have used GitHub or Bitbucket. You can think of this service to a replacement of these two services so that you can use it as a source control system. Now question is, why should you use AWS Code Commit? First of all, it is fully managed. So AWS Code Commit eliminates the need to host, maintain, backup, and scale your own source control system. The service automatically scales to meet the growing needs of your project. As a consumer, you don't have to worry about server maintenance. You can just start creating repositories through AWS console and start collaborating on it. So you don't have to manage any infrastructure or server. The second advantage is it is secure. So AWS Code Commit automatically encrypts your files in transit and at rest. You can transfer your files to and from AWS Code Commit using HTTPS or SSH as you prefer. Your repositories are also automatically encrypted at rest through AWS Key Management Service. Using customer AWS Code Commit uses AWS Identity and Access Management to control and monitor who can access your data and where they can access it. Code Commit also helps you monitor your repositories via AWS Cloud Trails and AWS CloudWatch. So you can collect all those metrics like who has accessed my service, my repositories, and who has access to them. The third advantage of using Code Commit is its high availability. So AWS Code Commit has a highly scalable, redundant, and durable architecture. The service is designed to keep your repositories highly available and accessible in case of any hardware or network failure. AWS Code Commit store your repositories in Amazon S3 and Amazon DynamoDB. Your encrypted data is redundantly stored across multiple facilities. The architecture increases the availability and durability of your repository data. So you are not going to lose any of your source code. It's always available. Another advantage of using AWS Code Commit is collaboration on code. So AWS Code Commit is designed for collaborative software development. You can easily commit, branch, merge your code, allow you to easily maintain control of your team's projects. Code Commit also support pull requests, which provide a mechanism to request code reviews and discuss code with collaborators or your fellow developers. You can create a repository from the AWS Management Console, AWS CLI, or AWS SDKs and start working with the repository using Git. So you don't have to learn any new tool, you can use just Git commands. So AWS Code Guru AI service is also easily integrate with AWS Code Commit, and which does automatic code reviews for you. So next is advantage of using AWS Code Commit is faster development lifecycle. So AWS Code Commit keeps your repositories close to your build, staging, and production environment in the AWS cloud. You can transfer incremental changes instead of the entire application. This allows you to increase the speed and frequency of your development lifecycle. You can now receive notifications for your events impacting your repository. Notifications will come in the form of AWS SNS notifications. No learning curve. You can use the AWS Management Console, AWS CLI, and AWS SDKs to manage your repository. You can keep using your preferred development environment, plugins, continuous integration in continuous delivery systems, and graphical clients with Code Commit. You can also use Git commands or Git graphical interfaces to interact with your repositories or source files. AWS Code Commit supports all Git commands and works with your existing Git tools. So there is nothing new you need to learn. All of your Git related knowledge your developer can still utilize. Now we know what is AWS Code Commit. Let's log into AWS console and play with it. Now I'm logged into AWS console, and if you see, I'm on the EC2 dashboard. In order to go to AWS Code Commit, type in the search bar as AWS Code Commit. You will see service listed there, and now click on it. Now we are on AWS Code Commit under developer tools. In order to create a repository, click on create repository button, and then it will open up a screen to fill repository detail. Let's give a name to it to AWS demo repository and add some description, maybe like this is my secure repository. You can specify tags also. Let's add a tag repository name is equal to secure demo repo. If you see down there, you can enable Code Guru API service, which enables automated code reviews reports for you, its source code. Currently it is only available for Java and Python source code. Code Guru service can identify issues in your code and also provide you insight related to any security vulnerability. But be careful before you enable this service, as it can be costly depending on your repository size. I was playing around this service and left it on for one night, and next day my bill was charged, like I was charged about like $120. So it is not very cheap, it is costly. So I'll say don't enable for this purpose of this demo. Now let's create on create button to create this repository. Now our repository is created, and you can see that you can connect with it using HTTPS or SSH. You can now see in the left side your source code, pull requests, different branches, commits, tags, and setting. In setting menu, you can enable triggers and notifications to notify about any commit. Let's try creating a trigger. You can list all the events on which this trigger can be kicked off. Let's select delete branch or tag, and you can select what action you want to perform on this trigger. Either you can select an SNS notification, or you can execute an AWS Lambda. If you choose a Lambda, you need to select the name of the AWS Lambda function which you want to execute, and if you choose a SNS notification, then you need to choose the SNS topic. I'm not going to create this trigger, so let's discard this. There are a lot of things in Code Commit you can do, but since this is an introduction lecture, so we are not going to look through everything. Let's go to repository and copy the URL, and then we go to terminal window and type git clone and repository URL to clone this new repository. Now if you see, it is asking for our credentials, which I don't have at this moment as I haven't created the user which have access to code commit, but we are now able to create a repository and I'm able to connect to it from my local system. Now, so you see now how easy it is to play around with AWS Code Commit. Now we understand what is AWS Code Commit. Let's talk about another service called AWS Code Build. AWS Code Build is fully managed continuous integration service that compiles source code, run test cases, and produce software packages that are ready to deploy. With Code Build, you don't need to provision, manage, and scale your own build servers. Code Build scales continuously and process multiple builds concurrently. So your builds are not left waiting in a queue. You can get started quickly by using prepackaged build environments, or you can create custom build environment that use your own build tools. With Code Build, you are charged by minutes for the compute resources you are using. Let's look at some of the advantages of using AWS Code Build. First of all, it is fully managed. So AWS Code Build eliminates the need to set up, patch, update, and maintain your own build servers and softwares. There is no software to install or manage. As a consumer, you don't have to worry about server maintenance. Second thing is, it is cost effective. With AWS Code Build, you are charged based on the number of minutes it takes to complete your builds. This means you no longer have to worry about paying for ideal build server capacity. Second thing is highly scalable. So AWS Code Build scale up and down automatically to meet your build volume. It immediately processes each build you submit and can run separate builds concurrently, which means your builds are not left waiting in a queue. You can continuously keep building and submit as many as builds you want. It will scale automatically. Next thing is extensibility. So AWS Code Build provides pre-configured build environment for Java, Python, Node.js, Ruby, Go, Android, .NET Core, for Linux and Docker. You can bring your own build tools and programming runtimes to use with AWS Code Build by creating customized build environment in addition to pre-packaged build tools and runtime supported by Code Build. You can package the runtime and tools for your build into a Docker image and upload it to the public Docker Hub repository or Amazon EC2 container repository. When you create a new build project, you can specify the location of your Docker image and Code Build will pull that image and use it as the build project configuration for you. Next thing or next reason to use AWS Code Build is it is secure. With AWS Code Build, your build artifacts are encrypted with customer specific keys that are managed by the AWS Key Management Service. AWS Code Build is integrated with AWS Identity and Access Management, so you can provide granular controls over which user and AWS resources have access to your builds. Next advantage of using AWS Code Build is integration support. So AWS Code Build belongs to a family of AWS code services which you can use to create complete automated software release workflows for continuous integration and continuous delivery. You can also integrate Code Build into your existing CI/CD workflows. So it is not just like you have to use AWS product, you can configure and use it along with your existing tools. For example, you can use Code Build as a worker node for your existing Jenkins server setup for distributed builds. You can use the AWS Code Build console, AWS CLI, SDK, and APIs or Amazon CloudWatch to view detailed information about your builds. What are the different metrics is related to how many builds have been successful, how many failed. So AWS Code Build shows you information such as the build's start time, end time, status, commit ID. Code Build also stream build metrics and logs to your CloudWatch. So you can still use CloudWatch to look all metrics is related to. You can use CloudWatch to create a custom dashboard, set a CloudWatch alarm, troubleshoot build issues, or inspect build logs. Now let's look at the another service from AWS called AWS Code Deploy. So AWS Code Deploy is a fully managed deployment service that automates software deployments to a variety of compute services such as Amazon EC2, AWS Fargate, AWS Lambda, and your on-premises servers. AWS Code Build makes it easier for you to rapidly release new features, helps you avoid downtime during application deployment, and handles the complexity of updating your applications. So you can do blue-green deployment using AWS Code Deploy. You can use AWS Code Deploy to automate software deployments, eliminating the need for manual and error operations. The service scales to match your deployment needs. So this service automatically scales. Now we understand what is Code Deploy. Let's look into some of the benefits of using Code Deploy. First of all, automated deployments. So AWS Code Deploy is fully automates your software deployments, allowing you to deploy reliably and rapidly. You can consistently deploy your application across your development, test, and production environment, whether deploying to Amazon EC2 or AWS Fargate or AWS Lambda or your on-premises servers. The service is scaled with your infrastructure. You can easily repeat an application deployment across different groups of instances with AWS Code Deploy. So it is not necessary you want to deploy all in once. You can deploy into the groups. So Code Deploy uses a file and command-based install model, which enables it to deploy any application and reuse existing setup code. Eliminating manual steps from deployments increase both the speed and reliability of your software delivery process. Next advantage is minimize downtime. So AWS Code Deploy helps maximize your application availability during the software deployment process. It introduces changes incrementally and tracks application health according to configurable rules. Software deployments can easily be stopped and rolled back if there are errors or something is not going correctly. With a blue-green deployment, the new version of your application is launched alongside the old version. Once the new version or revision is tested and declared ready, Code Deploy can shift the traffic from your prior version to your new version according to your specifications. So blue-green deployment is really easy using AWS Code Deploy. Next benefit is step-by-step detailed report. So AWS Code Deploy allow you to easily launch and track the status of your application deployments through the AWS Management Console or the AWS CLI. Code Deploy gives you a detailed report allowing you to view when and where to each application revision was deployed. You can also create push notifications to receive the updates about your deployments. You can launch, control, and monitor deployments of your software directly from the AWS Management Console or by using the AWS CLI SDK or APIs. You can pinpoint the scripts experiencing failures. You can also set push notifications that allow you to monitor the state of your deployment via SMS or email messages through Amazon Simple Notification Service or SNS. One application can be deployed to multiple deployment group. AWS Code Deploy tracks and stores the recent history of your deployments. You can view which applications versions are currently deployed to each of your targeted deployment groups. You can inspect the change history and success rates of the past deployment to specific deployment groups. You can also investigate a timeline of past deployments for a detailed view of your deployment success and errors. Easy to adopt. AWS Code Deploy uses a file and command based install model, which enables it to deploy any application and reuse existing setup code. Code Deploy uses a single app-spec configuration file that you can use to run actions, tasks, or verification at each lifecycle event, phases of deployment basically. So it is a sequence of lifecycle event. The commands can be any code such as a shell script, a custom program, or even a configuration management tool. AWS Code Deploy is platform and language agnostic, so works very well with any application and provide the same experience whether you are deploying to Amazon ECR, AWS Fargate, or AWS Lambda, or you are deploying it to your own premises servers. You can easily reuse your existing setup code. Code Deploy can also integrate with your existing software release process or continuous delivery tool chains. AWS, like, it is easily integrated with your code pipeline, GitHub, Jenkins, blue-green deployment. So AWS Code Deploy supports blue-green deployment and targeted deployment. So you can particularly target only certain number of instances where you want to deploy, or you can select blue-green deployment where that certain set of AWS services can be deployed at once. Free deployment. So there is no cost associated for deployment to EC2 instances. Zero, there is a cost associated when you deploy to on-premises services, and that is also very negligible. So it is 0.02, so it is basically 2 cents for each on-premises instance. That is like nothing. It's really cheap. Now let's take a look at the AWS Code Pipeline service. So AWS Code Pipeline is fully managed continuous delivery service that helps you automate your release pipeline for fast and reliable application and infrastructure updates. Code Pipeline automates build, test, and deploy phases of your release process. Every time there is a code change based on the release model you define. You can think of AWS Code Pipeline as an orchestrator to compose different commands and AWS services in the form of stages to automate your software delivery. You can easily integrate AWS Code Pipeline with third-party services such as GitHub or with your own custom plugin. With AWS Code Pipeline, you only pay for what you use. There are no upfront fee or long-term commitments. If you look at the below image, you can guess that how your change from code commit to build, test, and deployment to staging environment and then promotion to production are paired together. This entire process is referred as pipeline. Let's look at some of the benefits of using AWS Code Pipelines. So first thing is faster delivery. So AWS Code Pipeline automates your software release process, allowing you to rapidly release new features to your users. With AWS Code Pipeline, you can quickly iterate on feedback and get new features to your users faster. Automating your build, test, and release process allow you to rapidly and easily test each code changes and catch bugs while they are small and simple to fix. You can ensure the quality of your application or infrastructure code by running each change through your staging and release processing. Customizable workflow. A pipeline defines your release process workflow and describe how a new code change processes through your release process. AWS Code Pipeline allow you to model the different stages of your software release process using the console interface, the AWS CLI, AWS CloudFormation, or the AWS SDK. You can easily specify the tests to run and customize the steps to deploy your application and its dependency. AWS Code Pipeline provides you with a graphical user interface to create, configure, and manage your pipeline and its various stages and actions, allowing you to easily visualize and model your release process workflow. So you can see it step by step that how your code is going from one stage to another state. Another benefit is managed service. So with AWS Code Pipeline, you can immediately begin to model your software release process. There are no servers to provision or there is no setup required. Code Pipeline is fully managed continuous delivery service that connects to your existing tools and infrastructure. Next benefit is easy to integrate. So AWS Code Pipeline can easily be extended to adapt to your specific needs. You can use your pre-built plugins or your own custom plugins in any step of your release process. For example, You can pull your source code from GitHub or AWS Code Commit. You can use your on-premises Jenkins build servers, run load tests using a third-party software or service, or pass on deployment information to your custom operations dashboard. So AWS Code Pipeline can pull source code from your pipeline directly from AWS Code Commit, GitHub, Amazon ECR, or Amazon S3. It can run builds and it can run builds and unit tests in AWS Code Build. Code Pipeline can deploy your changes using AWS Code Deploy, AWS Elastic Beanstalk, Amazon Elastic Container Service, or AWS Fargate. So it is very much flexible and configurable to integrate it with any of the existing tools and technology. You can model AWS Cloud Formation actions, what you provision, updates or delete AWS resources as part of your release process. Another benefit is pay what you use. So AWS Code Pipeline is very cost effective and there is no upfront cost associated to you. You can only pay what you use. AWS Code Pipeline costs just $1 per active pipeline per month. Another advantage is built for CI/CD. So AWS Code Pipeline is natively built for continuous integration and continuous deployment, and it fits agile development to reduce time to market. So that's a huge win if you are using AWS Code Pipeline. So now we understand different AWS tools we will be using in deploying our microservice to AWS clouds. So let's take a closer look at the architecture of the application. If you look at the below diagram, in the right side you can see there is a user which makes a request to our application by typing the DNS name of the load balancer. Our EC2 instance are front faced by the load balancer, so load balancer transfer that request to one of our EC2 instances, and that's how our microservice respond to user requests. Our EC2 instances are deployed under an auto scaling group and protected by the security groups. Now let's look at the left side of the architecture, that how that microservice is being deployed to EC2 instances. At left you see a developer who creates the microservice using Spring Boot and Java and uses Maven as a build tool. Developer is using Spring STS as an IDE for software development. By the way, here the developer is myself. Other than the source code for the application, there is a build spec file and a application YAML file, which is packaged within source along with some script files, which I explain later in this video. Like once source code is completed, I will commit this source code to GitHub here, and we are not using AWS Code Commit as we want to show you that how you can integrate your existing source code repository to the AWS Code Build. Once code is committed to the GitHub, Code Pipeline will start the build stage and check out our source code from GitHub, and Code Build will kick off. Once Code Build is fully build it will collect the artifacts as specified in the build spec file and pass on to the deploy stage. In deploy stage, AWS Code Deploy service will use these artifacts and performs the deployment to our targeted auto scaling group and update our EC2 instances with the new version of the application using the app spec YAML file. Now we have explained everything that what we are going to do. So as a first step, let's go to https://start.spring.io to generate a Spring microservice template. Then once we have this template ready, we will make some changes to this service and deploy this to AWS environment. We are using Spring Boot latest stable version 2.5.0. Now let's change the package information for our demo app and also artifacts ID to code pipeline -demo. We have also specified the description or modified the description for this application. We are using Java 11 and packaging as a jar file. So Spring Boot comes with several starters which include required dependencies. For our demo, we just need one dependency, Spring Web. So let's add that. Now we are done creating our projects. Let's click on the generate project in the form of a zip file. Once you click on the generate button, it will create the project we needed. Now project zip file is ready, so let's unzip it and open our Spring STS IDE to import this Maven project in IDE. So in IDE, click file and then import, and import project as an existing Maven project and click next. Now browse the project directory and click open. Now our project is listed and click finish. Once you finish, you can see your project in the left panel, and now right click the project and click run as Maven build. It will ask for Maven command to run, so let's use clean, install and apply. So whenever you run as Maven build, it will clean the target directory and build the package you need. Now you can see that application build is started and Maven is downloading the required dependencies and building the artifacts for us. While the code build is in progress, we can look through the source code and notice that there is only one Java class called Code Pipeline Demo Application.java. If you open this file, it is just a Spring Boot application starter, which is a main with a main method and doesn't contain any specific logic. Now let's create a new Spring REST controller in order to call from our browser, which can indicate that our application is up and running. Click on the package directly and right click and select new class file. Let's name it welcome controller.java. Now our controller class is created. First thing what we need to do is to add the @REST controller annotation to the top of the class, so that Spring recognize this class as a controller class and treats this as a REST controller. Now what we need to do is we need to add a new public method to this class, which can be invoked remotely from browser and respond as string output. So let's add it as public string say hello. We are going to return a hard-coded string value from this method, say hello microservice in AWS Cloud. So this is a simple starting string which can be written from our service. Now I'm going to add get mapping annotation to this method and add a slash as a URL pattern, so that whenever a user invokes the context root of our application, this method gets executed. Spring support different HTTP methods, but we are going to use get commands here, or get method here. Now our REST controller is ready to receive traffic. Next step is that we want to change the default Spring Boot Tomcat port 8080 to port 80, so that our application can accept traffic on the default HTTP port. So that to do that, let's open the application.properties file within the resources folder and add the property server.port equal to 80. Now save everything and start the application by right click and run as Spring Boot. Now application is started. Let's go to the browser and type http://localhost:80, and you can see that our application responded with the message hello microservices in AWS Cloud. Now we are done creating our application and we are done writing our microservice code. As a next step, we will be deploying this application into AWS Cloud and creating all the required infrastructure in the cloud. Meantime, please like and subscribe to my YouTube channel. I will see you in the next part of this tutorial. Thank you.